At this time, we'll hand the net over to Jim, AI5EG. Good evening, Jim. Look forward to the presentation and discussion. This is K5LK.
Thank you very much, Bill. I appreciate it. Tonight, we're going to discuss wire antennas for HF. This is the Crossroads Ham Radio Club Tech Net number 12. My name is Jim. My call sign is AI5EG, and I'm located near Harwood, Texas. So hams love their antennas, messing around with antennas. So now is a great time to get onto the HF bands. The 11-year sunspot cycle is peaking. There are literally contacts from all over the world. I saw Malaysia, India, countries in Africa, countries in South America, just while we were waiting to check into the net. So also the weather is great for parks on the air, and wire antennas are easy to build. They're fun. You can experiment, you can tune, and fall in love with messing around with antennas. Now the possibilities for wire antennas are nearly unlimited. You can get on the internet, you can get the ARRL antenna handbook, but tonight we're just going to put our toe in the water and talk about a dipole and the antennas that you see here due to our time limitations. But before we get started, I want to make sure we're all on the same wavelength. Some terms. If you're building a antenna for a lower frequency, the wavelength is going to be longer and all the wires are also going to be longer. And for the higher frequencies, your antennas, the wavelength is shorter, and the antennas will consequently also be shorter. And a fun fact, if you take the frequency and multiply it by the wavelength, you will get the speed of light. So in our antenna system, there's going to be something called impedance. This is the kind of overall resistance to current flow, RF current flow, that goes into the antenna. And impedance basically consists of two parts. The real resistance. The resistance is what dissipates the power from your transmitter. And it includes the power that we want to transmit into free space, but it also includes losses that we want to minimize in antenna design. Now, reactance is the part that resists current flow without dissipating any power. It's kind of the yin and yang of the part of reactance, and these reactances vary with frequency. So for a good antenna, we want to have our antenna impedance around 50 ohms, resistive, and a low amount of reactance to get that wonderful one-to-one match that we all seek. About two versions here, what generally called a dipole and an inverted V. And in my mind, these are basically the same antenna, both dipoles. One of them is configured a little bit different. The half-wave dipole, the overall length is a half wavelength of the frequency you're going to use, and each side of it is a quarter wave. The inner conductor is connected to one side, and the outer braid to the other, and you have an insulator in the middle for the, and then that connects to the transmission line. For the inverted V, it's basically the same configuration, only the ends are draped down in a upside-down V configuration. These are widely used, easy to make, cheap. They are directional to the broadside, perpendicular to the wires. And in comparing one to the other, the dipole is slightly more gain broadside, and the inverted V is a little more omnidirectional. Generally, at normal heights, you get a better match for 50 ohms with the inverted V. The dipole is a little higher impedance, up in the 60, 70 ohms. The nice thing about the inverted V, you just need a single support mast in the middle. That's another good feature for inverted V style. Now, to make these, there's a lot of information on the internet and in articles, and also a lot of hams with experience in the club can help you out here. But there is a wire length formula that will get you close. It's the overall feet of a half wave is, we appreciate, 468 divided by the frequency in megahertz. And if you're going to take your general or extra class exam, you probably need to know this formula. For example, a 40-meter phone band, 7.2 megahertz. If you do the math, you get an overall length of about 65 feet, or of 65 feet, and half of that would be 32 and a half for each quarter wavelength. Set it a few feet longer and fold the excess back over the ends. That way you don't cut it off too short. You're going to check the standing wave ratio and adjust the length as needed. And to make adjustments, you need a vector network analyzer, VNA, or your SWR meter. You can do it that way, kind of old school. And I think Phil's going to give us a lesson on VNA here in a future Tech Net. Look forward to that. I like RG8X. You can also use RG58 for the coax speed, unless you're running like legal limit power. RG8X will handle a few hundred watts easily, and for HF bands, it's lower loss than RG58. It's very flexible, easy to work with. And in your antenna construction, you'll need an insulator on the ends. These are showing what they call dog bone. I mean, I've used electric fence insulators on one of my antennas, and you need some kind of insulator support in the middle, especially inverted V. You're going to need to hang it up. Lots of different designs. I made one out of PVC for one of my antennas. And when you connect your coax, you're going to want to weather seal this, either with self-bonding silicone tape if you have a connector, or I like to use liquid tape, or if you must, you can use electrical tape, although it gets kind of messy when it's weathered. And off you go. So that's the dipoles, both inverted configuration and a regular straight across. They're just going to work on one band, whatever frequency you cut that wire to, with one exception. We'll get to in a minute. So how can we make a multi-band wire antenna? Well, two really good ones. First of all is the fan dipole, which is a great antenna. And we just simply take all of those dipoles, all the different lengths, and just hook them all up to the middle, just like it was one with the feed line. Now, there's many ways to spread the wires outward. I think you can be a little creative with this. Either run them parallel, like the one in the upper right there, or down in the lower right is actually a photo of my fan dipole. I gave it to Monty, K5KXF, but I think one of the 80-meter wire goes on top, and the 40-meter is almost diagonal to that, or right angles to it. The nice thing is you don't need a tuner, you don't need a band switch. Once you got it all tuned up, it's very efficient. And in a dipole, at resonance, the minimum impedance is in the center of the antenna, which has the least resistance to the RF flow. And so the resonant antenna is going to naturally take the transmit power, and also naturally take in the receive power. The antennas work equally well for transmit and receive. All of the characteristics are the same. Reciprocity. One little bonus, the 40 meter wire, which is 7 megahertz band, will work at the 15 meter, 21 megahertz band because dipoles will resonate at odd multiples of the base frequency, and 7 times 3 is 15. I think this is the only place this works out to where the odd multiple falls in a ham band. I could be wrong about that. One really good tip is to separate the antennas at the feed point. If you wire it like the diagram here above, and in fact, where I got this diagram later on in the text, they updated it to recommend the separation. Then when you adjust one of the wires, it will affect the others, and you wind up kind of chasing yourself in circles trying to get it tuned. But if you just separate it 10, 12 inches, or even less, it makes it a lot less. There's a very high field strength right at the feed point, and the other antennas can interfere with the tuning. So I definitely recommend you do that. You can make something homemade like these, or maybe there's something available. And by the way, on all these pages, I have some links at the bottom. You can do some more where I got a lot of the information from. So feel free to look into those. Band dipole works great. A lot of wires flying around though, so that's one of the things you got to be aware of. I guess that's one of the downsides. The next one I want to talk about is a multi-band trap dipole. And the example here from K7MEM, and I definitely recommend you check out this guy's website. I got a link to it at the bottom, and then also his generic website at the end. This is just a 2-band version. I think he's got a 5 or 6 band one on there as well. But just to show you, the nice thing is you have one wire from the insulator to the insulator, and in this case he's using a balun in the middle. You cut the 40 meter antenna and tune it just like you would the 40 meter we talked about earlier. But instead of an insulator, we're going to put in a trap. And a trap is a parallel inductor capacitor circuit. And the trap, it's a little schematic diagram there that I put up in the picture. The trap's resonant frequency, it's a very high impedance, and it blocks the RF. Say if you want to tune the trap to the 7.2 megahertz we talked about earlier, it blocks it from going further down the wire, and essentially you've got your 40 meter dipole going right there. You can get a good match on all bands. You don't need a tuner, and you don't need a band switch. Might be an easier antenna to put up. And the coils in the traps, the more you put, the shorter the antenna gets for the lower bands. The example above, the 80 meter is about 4 to 5 feet shorter than a normal calculated 80 meter length. And kind of going back to the trap, when you're not at resonance, the RF just goes basically straight through the coil all the way to the end for the lower frequencies. And it becomes kind of a shortened dipole, which is another type of antenna. Now there's some loss associated with the traps, but if you have a shorter antenna, it might give you the chance to get an 80 meter antenna on your property, or maybe in your attic or something like that. Also, let me let it drop. The 10 and 12 combination, you can't do both of those, and the 15 and 17, you can't do both of those because the frequencies are too close together for the traps to work properly. And another kind of downside, this odd harmonic trick, we call it, the 15 meter working on a 40 meter, won't work because the trap does not stop the odd harmonic. It just keeps going on through. Some information here, the K7MEM right there. he's got several different trap designs, and the nice thing about his website, he's got all the calculators built right into the website. So I really like that guy's work. If you want to build an antenna like this. And now, the in-bed half wave. Some say it's a cult phenomenon. And there's Brenda, KJ580O. Look at that antenna she's holding in her hand. You could stick that in your pocket, in your go bag, take it with you on a motor trip. When the zombie apocalypse comes, you could take it to your bug out location. So this antenna is fed from the end with a transformer rather than the middle, but it's still a half wavelength radiating wire. Requires a 49-to-1 transformer, also called an unbalanced to unbalanced. I have a hard time saying that, to match to the 50 ohm coax. We're not feeding in the middle where the impedance is low anymore. We're feeding from the end. The impedance at the end is very high. The voltage is very high, and the current is low. So here's an example of a transformer that my daughter, Avery, WE5GAL, built from a kit. It's been up for about a year when I opened it up here to take a picture. And you can see the toroid with the wire windings inside the transformer. On the left is a lifting eye to hold it up and the antenna connection. And on the right, the coax connector, EL239, and a wing nut for the counterpoise wire, which we'll talk about in a minute. Okay, a lot of advantages. Very lightweight. I mean, portable. People are just going crazy over this. I know of so many hams that have these. We have one here. It's not up right now. Easy to deploy. Can be a stealth antenna. Great backup antenna. It should be in every ham's bag of tricks. It works well on 40, 20, 15, and 10. So it's a really super antenna. I know a lot of hams that this is their only antenna. But there is a theory, I guess, that a counterpoise is not required. And I'll talk about what a counterpoise is, but there's a fact that all antennas require a return path for the radiated RF currents. If you don't provide a path, the RF will find a path. And if there's not a path available, your antenna just won't work. So without a counterpoise in the feed line, without a counterpoise, the feed line itself and also your radio and all the cables connected are going to be part of the return path. This can cause RF interference in your shack when you're transmitting. It can cause the pickup RF noise from your shack when receiving. Can affect the standing wave ratio, tuning, and efficiency. Now, for low power, going out in the field, PODA operation, QRP, probably not a concern. The coax feed line will be fine. But if you're going to use this as a main antenna, you could have dangerous high power, dangerous RF voltages and fields could be present in your shack if you're going to run power with this thing. How do we mitigate this? There's a website at the bottom, TA9X, that talks more in depth about it. But one way to do it is with a counterpoise wire. And this is a wire that's connected to the ground terminal of the coax connector and just out hanging down, I guess. And for 40 meters, about 17 feet of wire, it's not meant to be resonant at the transformer connection, and this gives the RF path to come back. And you'll need to insert a common mode choke. I'm not going to go into the details of that. You can buy them or make them up near the transformer. And the common mode choke prevents any RF from its common mode from going up and down the coax speed line. The differential mode RF, which is the RF that you want, will go on through because it's not affected by the common mode choke. Another way to do it is to put 2 meters or 4 meters of coax in between the transformer and your choke, and then that little section of coax will provide the return path for your RF. So those are 2 ways to do it. They're discussed in more detail in the website that's down at the bottom of the page. I live on a small ranch. I have no restrictions. I can do whatever the heck I want, but I think many hams are in HOAs and things like that, and you got to be a little sneaky about it. But any antenna is better than no antenna at all, so try to look up some clever ways to have an antenna. Bill recommended me that we look into this one, the rain gutter antenna. And I'll just say right from the get-go, this is basically an infed with a gutter and downspout for the wire, but it's not tuned. And this is also would be a long wire antenna, the exact same setup. You have a longish wire instead of your gutter with an automatic tuner connected to it, and off you go. I have a good friend at the coast that uses this setup, and he gets some really good results. His isn't the gutter, but his is on a long wire out over the bay. So on the right is the actual implementation. I looked at several. This is the one I like the best. This little box here is an automatic tuner. It tunes the antenna whenever you start transmitting. It's connected to the downspout, the downspout is not connected electrically to ground. There is a ground rod, probably 6 or 7 feet of rod hammered into the ground. Here you can see at the bottom with radial wires or counterpoise wires at the bottom. So this setup, I think I would put a common mode choke where it comes into the house just to keep the RF outside if I were going to set this up. This website here, fullduplex.com, talks about this antenna in more detail if you're interested in doing that. Now, one caution, the antenna is being fed at the end. The downspout is going to have RF voltages on it, in particular if you're going to run any power. I'm not sure I'd run power with this antenna, but you might want to put a little fence around it or make sure you don't have children out there to get an RF burn from the downspout. And I'm not sure if it'll work with a metal roof. I just don't know. So anyway, there's your rain gutter antenna. Also, same configuration for a long wire. Next, some ideas that I just found on the internet. I like these on the right, up in your attic. You've got some fan dipole action. A couple of different ways to hook them up. If you like crawling around your attic to do this, but you can hide it pretty good. Not going to work with a metal roof though. KG7MCH found this picture. It looks like he's got his feed point coming out the vent, and I guess a dipole or something going around under his eaves. Just a sneaky way to get the antenna up there. And one I found that I thought was interesting, there's a YouTube video that's linked there on this broadband butterfly terminated dipole antenna. This is reminiscent of a rhombic, which is a really big antenna, quite used in the military quite a bit, where they've got their wire going all the way around the house and a 16-to-1 balun. If you're interested in this, watch this video. He goes into all the details of making it. It does have max gain in the direction shown, so you may want to put your house on a rotator or something like that if you want to turn it around or something. But anyway, it's an interesting configuration. And at this point, I'm pretty much done. There's many other antennas. I had quite a few others. I was going to talk about G5RV. and off-center fed dipole. Some of the material is in the appendix coming up, and I definitely recommend you check out Martin Messer's K7MEM website here, k7mem.com, and look at all the things he's done. I think he spent nearly 20 years developing this website. It's kind of a life work, so I appreciate it. And with that, I will turn it back over to our net control, K5LK, Mr. Bill number 2, AI5EG.
Bill number 9, but you got it pretty close there, Jim. Great presentation. This is K5LK for the Crossroads Ham Radio Club's Tech Net number 12. Awesome presentation. Look forward to the discussion tonight. Okay, we're going to open the net for any questions or comments specific to tonight's presentation from Jim on HF wire antennas. We'll take a few call signs at a time and then call on each of you for your questions or comments. Anyone with questions regarding the presentation or comments, please give your call sign phonetically, slowly, followed by your name. This is K5LK.
Whiskey 5 Bravo Sierra Alpha. Whiskey 5 Bravo Sierra Alpha. Joe with the question.
Kilo India 5, Yankee Oscar Lima. Kilo India 5, Yankee Oscar Lima with a question. Nathan.
All right, we'll start with the first two, W5BSA Joe and KI5YOL Nathan. Go ahead, Joe. Good evening.
Hey, good evening, Bill and the net. Fantastic program, Jim. Thanks so much. My question for you is, I've always wondered, if you've got the real estate, is there any advantage on any of the dipole antennas to use in a full wave, or would there even be a disadvantage to using a full wave versus a half wave, for example?
That's a good question. Full wave. I think the full wave. Look at my. So this would be. So a full wave. If you look at slide number 25, you will see kind of a diagram here. I was trying to show why the 40 meter and 15 meter can work. In a full wave antenna, it would be like, if the it would be like two half waves. That would be the diagram in the middle, and that's not going to work. It's not going to be possible. You could do a 3/4 waves, I think would work. 3 half wavelengths, if I'm getting this right. So a full wave, you would have high voltage at the end of the antenna, and it would need to have current at the end, and you can't do that. The wires, there's no more wires, so no current can flow there. My opinion, I could be wrong about this, is it's not going to work.
Thank you.
Did that answer your question, Joe?
However, if you want to build a long wire, longish wire, and avoid having it resonant at anything in particular like that, that's another way you can get a longer wire. I think it's going to just change the radiation patterns. Overall, as long as you're getting all the RF into the antenna, it's going to go somewhere. So you'd want to model that to see any antenna to kind of see what the directionality is, I would think.
Thanks very much. Appreciate it. Makes sense. W5BSA, back to Ned.
Alrighty, this is K5LK with TechNet number 12 on the Crossroads Ham Radio Club's link repeater system. Over to Mr. Nathan, KI5YOL. Go ahead, sir.
Thank you, Bill. Quick question about random wire antennas. Seems like you were starting to touch on it a little bit with with Jim there. Just if you could touch on them a little bit. And biggest question I have is about installation orientation, horizontal versus vertical. Is there one advantage over the other? As I know that they have a tendency to be in the horizontal, they're somewhat directional. Does vertical help alleviate some of that directionality?
Great question, Nathan. So you can build a vertical wire antenna, just like any vertical, with radials and things like that. It's going to have a vertical polarization. So, and you can buy verticals that are aluminum, and they're multi-band as well. And a vertical typically is going to have a omnidirectional pattern, if you will, rather than directional. So if that answers your question, or if you would like to continue your question, please go ahead.
Nope, you just confirmed what I was starting to find in my research, and wanted to hear a good opinion on it. Thank you very much, sir. KI5YOL, back to the net.
Okay, this is K5LK Net Control for the Tech Net number 12 tonight. We're talking about popular HF wire antennas. Taking anybody that has any questions or comments to Jim, please come now with your call sign phonetically and your name.
Whiskey 5 India Tango Zulu, W5ITZ, Bill from Ganado.
Good evening there, Mr. Bill. Go ahead, W5ITZ.
Thank you, sir. Jim, thanks for the presentation. Really, really good information. I did have a question on the in-fed half wave in reference to the counterpoise. I saw where the counterpoise is going to be connected to the ground terminal from the transformer. My question is in reference to the other end of the counterpoise. Should it be dangling in free space? Can it be connected to an earth ground? Or is there a preference, or is there a no-no either way?
Okay, bill number 1, AI5EG. Thank you. I am not 100% sure. The ones I've seen and read about, it's just dangling in free space. And that's what I've seen. I'd have to go do a little more looking into that. We might look at this website and see what they have to say. But mainly you're providing the return path for the RF that you're transmitting. So good question. I don't know the answer. The one that we built, that Avery and I built, we just let it dangle down the pole, and then we had to choke a few turns of the RG8 through a ferrite core up near the transformer, and it seemed to work pretty good. We didn't use this antenna a lot, though, so I can't say I have a lot of experience with it. AI5EG. Back to Bill.
Thanks, Jim. Appreciate the reply. W5ITZ.
Thank you, guys. Any other questions or comments for Mr. Jim's presentation tonight?
One more from W5BSA.
Go ahead, Joe.
Hey, Jim, I'm very intrigued. It looks like you've got quite a bit of testing gear and experimentation going on behind you. So my question for you, when you've built any antenna, what's the first piece of test gear that you reach for to see if everything's happening like you hope it is?
Yes, sir. Great question. Let me let the repeater drop. I have a nano VNA that I use. I hook that thing up, anxiously looking to see what the standing wave ratio is. And I also, if it's not right, I look at the Smith chart, which is kind of a lost art, I think. But yeah, nano VNA, and I think that I'm counting on my friend Phil, W5CPO, to do a presentation on how to use a nano VNA at a future Tech Net. It's a great piece of equipment, very cheap to own, and that's what I have.
Thank you, and I look forward to that, Phil. W5BSA.
You on the spot, buddy.
That's right. He's got to produce now, Jim, for sure. It's K5LK, net control for TechNet number 12. Jim, a couple of questions for you. The first one, are you currently, and you may have mentioned it, but I didn't pay enough attention. At your current QTH in Harwood, are you running any wire antennas? And if so, what are you using?
Yes, sir. I have a 160-meter off-center fed dipole, and I think it's similar to one that Bill has. I'm not like 100% happy with it. I'm thinking about changing out, but it works. I use it mainly on 80 and 40. The other wire antenna that I have a hex beam that I built from some instructions, and that would make a great Tech Net maybe down the road somewhere. And it works fantastic. So those are both wire antennas. And then I have a 2-meter Yagi, and that's pretty much it for my antenna farm. Over.
All righty. Thank you for that. And my second question is, and I think you alluded to it a little bit, talking about in-fed half waves in general. Why, besides the counterpoise, I guess, my first question is, why are they so popular? I think maybe you answered it. They're just very versatile, and you can pack them with you and things like that. But it seems like that's all the rave in our ham world for the last several years. And just, you wanted to expand on that a little bit, kind of why they're so popular?
I would say, just back to what we said earlier, they're lightweight, very portable. You can, if you make a proper adjustment, you can get on the good SWR on the main ham bands without a tuner. And you can even build one for 80. In fact, Avery and I built hers for 80 meters with a with a shortened 80 meter on the end. And it just seemed like, excuse me, I think it's just the ease of it. You can get them in kits like that. It's very appealing. You can just go to the park, throw the end up over a tree and get going. And like I said, you don't need to go to all the complexity of a multi-wire setup or the traps and all that kind of stuff. I don't think they are as efficient as, say, the fan dipole, but, you know, unless you're going for DX and it lasts a little bit of DB, it may not matter that much. So I think just they're pretty cute. I really want to get one like Brenda's. I'm going to go look for it.
All righty, so it sounds real good, Jim. Thank you. I'm going to have one more question, but I'll let you go ahead and ID AE5IG from K5LK.
This is AI5EG. Yeah, I think you could just ask, make this a question to the other members here that have them. I mean, what's appealing to them for them about it? So they'd probably get a more descriptive answer. This is AI5EG in Harwood, Texas.
What good idea. We'll go ahead and throw that out here where we're talking about in-fed halfways. Anybody got any comments that have been using them and what you like about them, what you've learned about them, maybe what you don't like about them that are currently using in-fed halfways for your HF antenna? Come now with your call sign.
Alpha Echo 5, India, India.
There you go. Good evening, Kelly. How you doing? Go ahead, sir.
Phil was in there, W5 CPO.
Oh, I must have doubled with him. Sorry about that, Phil. Phil, did you go first? Go ahead.
Go ahead, Kelly. You were in there first.
All right, sounds good. A couple of suggestions just for some light reading. You can do a Google search for a antenna called grass wire antenna. The guy's call sign is Kilo 3 Mike Tango. Just search for that on the internet. It's a non-resonant 203-foot long wire with a counterpoise, and he uses the counterpoise and the ground rod, or just actually a couple of counterpoises. And he actually ran this along the end of his privacy fence at his cabin up in Pennsylvania, and he worked places all over the world with a QRP. But it's very interesting reading. It's actually a antenna almost on the ground at about 6 inches elevation, and it radiates vertically polarized off the end of the wire. Very interesting article. And also look for 43-foot vertical. That seems to be some kind of a magic length. There's a lot of places that sell 43-foot verticals, and they're multi-band. There must be some special balun at the bottom or matching system or something, but I believe there's people running them even without a counterpoise, but that's very interesting. But when we went to Goliad, let me let her drop. I used Phil's homemade halfway long wire there, and the one end was right on the ground, and the other end was about probably 35 feet in a tree. And I hooked my little QRP rig to it and had a great SWR on it. We checked it with Brenda's antenna analyzer, and I was making contacts all over the states, and that was after a coronal mass ejection, and the forecast for the low frequencies was not good that day, and I made, I don't know, about 15 different contacts, but had a lot of fun. Only one doing CW out there. I guess that's my comment for the evening. Go ahead, AE5II.
Thank you, Kelly. That's grass wire antenna, Kilo 3 Mike Tango, and then the 43-foot vertical. A couple of ones to look up on the internet, correct?
That is correct.
Okay, thank you. Great comments. Over to Mr. Phil, the net logger. Go ahead, W5CPO from K5LK and Tech Net number 12.
W5CPO. I think the biggest benefit with the end-fed halfwaves is, number one, being that they're super portable, and they're multi-banded, and they're cheap. You can build these guys for, depending on where you're buying your stuff at, you can use a piece of wood to wrap your wire around and screw all your connectors to it and all that kind of stuff, and you might spend $50 at the most, on the wire for, you want to stay with a small wire, 22 gauge, 24 gauge wire, silicone jacketed, that way it doesn't get all hard and bendy. It doesn't want to bend, but and you only one end needs to be up in the tree. The other end is down on the ground, so they're easy to throw up and they're easy to talk on. No tuner required. That's all I got. Back to you, Bill.
Great comments, Phil. Thank you a lot on the InFed halfway. Appreciate it very much. Okay, let's wrap up the discussion, comments or questions about popular HF wire antennas for Jim. Anybody else have a comment or question for Jim? Please come now with your call sign phonetically and your name.
Yeah, 5 HVF, Kilo India 5, Hotel Victor Foxtrot, Darren.
Kilo Juliet 5, India.
Thank you there, Mr. Darren. Go ahead.
ICC, Gordon.
Yeah, there was a station from Wharton, I believe. Come on back with your call sign.
Kilo Juliet 5, India Charlie Golf.
Gotcha. KJ5ICG will be right with you. Over to Darren and Cena. Good evening, Darren.
Well, good evening, Bill, number 2, and everybody else on this Tech Net tonight. Hey, I just want to let everybody know I did post a couple of comments or a couple of links in the comment section on the antennas that Kelly was talking about for the K3MT, and also an article on EHAM about the 43-foot vertical. KI5HPF, back to net.
All right, very good. Good information. I believe is that Gordon, KJ5ICG. Go ahead with your comments or questions on the HF popular antennas tonight.
That's correct. It's Gordon in Richmond, Texas. I was just listening, just recently passed my general exam, listening for HF radios and was getting ideas on different antennas. What might be the most versatile if I have a transceiver that covers, say, 10 to 80 meter band? Trying to see what would be the most versatile for me to use.
Good question. I think the second question back to you, Gordon, is what type of real estate do you have there? How much do you have? Are you in an HOA, or that is not an issue with you?
It is a small lot in an HOA. Furthermore, we're just renting right now, so any kind of permanent antenna would be out. So something along the line. I thought maybe just researching, basically.
Well, congratulations. We'll get probably one of our POTA team members. They'll probably help you out. I see him here on Zoom. He wants to help Gordon. Go ahead and give us your call, please.
W5CPO.
Go ahead, Phil. Gordon's looking for your comments.
Gordon, if you have the room for it, put up a G5RV.
KJ5ADO.
Be right with you, Brenda. Phil, tell him why the G5RV, a little bit about that antenna, if you don't mind, and then turn it over to Brenda.
The G5RV is a lot like an ANFID halfwave when it comes to portability and storing it up in a tree. It's a lightweight antenna. They're cheap. You can build your own, or you can buy one for about $100 or so. And you can put it up horizontal, or you can use it as a dipole, or inverted V. So they're very versatile. You get all the bands with it, most of the bands anyways, 40 through 10, and go from there if you got the room for it.
Okay, yeah, I just
Okay, thank you, Bill. Good comment. Over to Brenda.
Talking about there, and that looks like something I can take with me. So my wife and I camp a lot, so that'd be something I could take to the campground, state parks usually, and set up kind of like a POTA setup, kind of like what you're talking about there. So yeah, that's definitely a good option. I appreciate that, KJ5 ICG.
I'll double with you just a minute. Let's turn it over to Brenda. This K5LK.
Brenda, KJ5ADO. I have another suggestion as well. ARRL has a in-fed half-wave kit that is 10 to 40, so it's pretty short. It's a nice little kit. It has great instructions. There's even YouTube videos that go step by step how to put it together. And my son, he has one too. He lives in a rent house as well, and he can take it down and go take it on POTA activations too. So there's another suggestion, kind of an easy thing to put up at while you're renting and while you're camping. This is KJ5ADO, back to Net Control.
Good comments there. And you're one of the IT graduates, aren't you, Brenda, from isn't that what they call it? Up at W1AW? Well, up at ARRL?
Yes, it's Teacher Institute, TI. And yeah, Phil's holding up the antenna book. That's a great book to get from ARRL as well.
That's right. I got IT and TI confused. Sorry about that. This is K5LK. Gordon, does that answer your question? If you can stay on Zoom or send an email to technet at CRHRC.org, we'll be glad to help you however we can with the antenna, sir.
Yeah, I'm actually looking at the kit right now on the ARRL website, so that's pretty intriguing too, to kind of get some hands-on and figure out a little bit more how it works myself. So that's interesting too. So yes, thank y'all for your recommendations, and I appreciate it, and I'll be listening. KJ5 ICG.
Again, welcome to the hobby. Congratulations on upgrading the general, and enjoy it. We're at the top of the cycle we talked about. Probably for the next several years ought to be great at HF. Okay, K5LK. We're going to finish up the RF portion here, just open it up to any tech-related amateur radio questions. If anybody has any questions related to the general portion of our hobby, the tech portion, please come now with your call sign phonetically and your name. Figured it might be a pretty popular topic, the HF antennas tonight. Sure was. Great job. One last call for any tech-related amateur radio questions or comments. Please come now.
AE5II.
Yes, sir, Mr. Kelly.
I just wanted to jam in a Trader's Net commercial for anybody that's needing a radio, looking for used radios. Check into the net on Thursday, and we'll catch you up on the Trader's Net. What's available for sale around here?
All right, sounds good, Kelly. And you usually have quite a few antennas listed every week too, don't you, sir?
Yes, sir.
Awesome. Appreciate you learning that. Okay, does anybody, before we close the RF portion of the net, does anybody else have any comments or questions for us tonight?
Whiskey Alpha 5 Yankee Papa Delta comment.
WA5YPD, good evening. How's it going? Go ahead, sir.
Good evening. Well, this is another one of the builds. I'm located down here in Bay City. I just wanted to comment on the G5RV. I've been running one for a long time. I have the feed point up about 40 feet, hung off the side of a tower, and the part coming down is a partial inverted V. They're still about 10 to 15 feet off the ground when they come back. And I do use the tuner, but I work all over the world with it. I just worked Australia just a little while ago on FTA, WA5Y50.
Awesome, Bill. Thank you for the comments about that antenna. Anybody else have any comments or questions?
CRHRC.
Over to you, Jim.
Yeah, great comments on the G5RV. I had it on the agenda. I know, Bill, we have friends that use them and they work great. I have a friend at the coast. He's not a club member that's got over 300 confirmed countries that uses the G5RV. And it's a great antenna. I think Brenda's and Phil's recommendations are great for the InFed or the G5RV. It's a great antenna. I just ran out of time to get to it. So anyway, definitely thumbs up for G5RV. Back to net control.
And that's the advantage of some of the topics we're talking about. We can have some Zoom sessions and we could spend, 2 or 3 hours on antennas or G5RVs or InFed half waves. So we hopefully get to do more of that. All we need is some more TechNet team members. So if you're interested in helping out and getting more topics, we'd love to have you. Just send an email to technet@CRHRC.org or hang around the Zoom session and raise your hand here in just a minute. This is K5LK. Before closing the net tonight, we'd want to get everyone an opportunity to check in on the RF. If you've not already checked in with a pre-check or Zoom or NetLogger, then now is your opportunity to do so. Please give your call sign slowly, phonetically twice. Please come now. One last chance for TechNet number 12, late check-ins. Please come now. Well, nothing heard. I'd like to thank everyone that participated in tonight's TechNet number 12 session. And many thanks for Jim, AI5EG. Great presentation and discussion around HF antennas. Really appreciate it. We want a big thanks also to our TechNet team members who helped to make tonight's TechNet a success. If you have any questions regarding the TechNet or would like to join our TechNet team, you can send an email to technet@CRHRC.org. Also note that many of us are going to remain in Zoom for just a general RAG2 session. We'd love to have you. We can continue the discussion on anything around ham radio. No politics allowed tonight. So we'll just talk ham radio. We'll close the RF session of the Crossroads Ham Radio Club's monthly TechNet. This is Bill, K5LK, returning the repeaters back to normal amateur radio use. 73, and good night all.
You have been listening to a TechNet presentation of the Crossroads Ham Radio Club. For more information on this club, go to www.crhrc.org. For information on upcoming TechNets, go to technet.crhrc.org.